Let's continue. So instead of finding the cell voltage given the ion concentration, so we can do the reverse. We can use Nernst equation to determine ion concentrations. So this is the most important use of the Nernst equation in chemistry. Given the cell voltage and the concentration of one species in the two half cells, the concentration of the other species can be calculated using Nernst equation. So for example, we are to consider the voltaic cell in which the following reaction takes place. So we have here zinc, which obviously undergoes oxidation because its oxidation number goes from 0 to positive 2. And we have here hydrogen, which undergoes reduction. Its oxidation number decreases from positive 1 to 0. So it is found that the voltage of the cell is 0.56 volts when the concentration of the zinc ion is 1 molar. So we have a capital letter M there to represent the concentration, and the pressure of the hydrogen gas is 1 atmosphere. So we are looking for the concentration of the hydrogen ion in the given voltaic cell. So just like what we did, because we're still going to use the Nernst equation, just like what we did in the previous examples, so we're going to write the equation in the anode and the cathode, and so that we will be able to find the standard cell voltage. So zinc undergoes oxidation. This is N2 plus 2 electrons. And for hydrogen, it undergoes reduction. So the standard oxidation and standard reduction, we're going to look for this in the table. So for zinc, that's negative 0.762 for the reduction, but we're going to reverse this because it undergoes oxidation. And for hydrogen, whether it undergoes oxidation or reduction, it's always 0 because that's the reference reduction potential. So again, for zinc, it becomes positive 0.762 volts, and this is 0 volts, so meaning the cell voltage is positive 0.762 volts. And then for N, obviously we can see that N is equal to 2. So this, we are going to need this for Nernst equation. So Nernst equation, E is equal to the standard cell voltage minus 0.0257 volts divided by N, ln of, so from the given equation, we can see that we are going to put the concentration of zinc in the numerator, multiply that to the pressure of the hydrogen gas, divided by the hydrogen ion concentration, that's raised to the power of 2, and we do not include zinc anymore because that is a solid. And we are now going to substitute. So this time, take note, remember nga atong gipangita kay ang concentration sa H+. So kani atong unknown. So basically everything else here is already given. So we're going to substitute. So this is 0.56. This is equal to 0.762 minus 0.0257 volts divided by 2 ln of, for the zinc it's 1 molar, for hydrogen it's 1 atmosphere, and we don't know the concentration of the hydrogen ion, that's raised to the power of 2. And so what we're going to do now, so let's Kay negative man ni siya, so ato ni siya ibalhin sa pikas. Unya kaning 0.56 atong ibalhin sa pikas. And then, because this is just 1 in the numerator, so we can just replace everything with 1. So this is 0.0257 over 2 ln of 1 over h plus squared equals 0.762 minus 0.56. So 0.762 minus 0.56, that's equal to 0.202. So take note nga wala na unit kaya ako nang gi-cancel ang unit on both sides. And then, so what we're going to do now, so this is 0.0257 over 2 ln of 1 over h plus squared. So this is a coefficient ng fraction. So what we're going to do is to cross multiply. So ang mahabilin sa left side is ln of 1 over h plus squared. And that's equal to 0.202 times 2 divided by 0.0257. And that gives us a fraction nga 4040 divided by 257. So take note that I am not rounding it off. I'm not expressing it in decimal because I don't want to round it off. So that's ln of 1 over h plus squared. And I want you to recall, diba? That's called ln because that's natural log. So when you say ln of x class, that is log of x base e, no? So magkag ln of x equals y, mura ka na nagsulat og log of x base e equals y. So when you change this to exponential form, ang mahabilin diri sa left side is x, and base man na si e, mahimo na exponent si y. So same here ito buhaton. So ang mahabilin diri sa left, ang 1 over h plus squared, o kani e raised to the power of 4040 over 257. And then, because naa si h plus diri sa denominator, ato na siya ipuli silang duha sa ilahang lugar. And so, that's 1 over e to the power of 4040 over 257 equals h plus squared. And then we're going to extract the square root. So the concentration of the hydrogen ion therefore is equal to the square root of 1 over e to the power of 4040 over 257. And when you extract the square root, that would give us an answer of that would give us an answer of 3.859 times 10 to the negative 4 molars. So that is our hydrogen ion concentration. Okay, example number 6. A galvanic cell is constructed in which the overall reaction is given, and then silver ions are added until silver bromide precipitates at the cathode, and silver has a concentration of 0.06 molars. The cell voltage is then measured to be 1.71 volts at a pH of 0, and the pressure of the hydrogen gas is 1 atmosphere. So we are to calculate the bromide ion concentration under these conditions. This time, we're looking for the bromide ion concentration. So first, we are to determine what half reaction occurs at the anode and what half reaction occurs at the cathode. So at the anode, sama na to, si bromine is 0, 0, negative 1, positive 1. So si bromine ni-decrease yung oxidation number, si hydrogen ni-increase yung oxidation number. So sa anode, si hydrogen, so H2, that's a gas, and then 2H plus 2 electrons. So its standard oxidation is 0 volts. And then for bromine, so we have Br2, that's a liquid, plus 2 electrons to produce 2 Br negative AQ, and the standard reduction is equal to, we're going to look at it for the table, and that is 1.077 volts. Okay, that's 1.077 volts, and that would give us the standard cell voltage of 1.077 volts. And we can see that N is equal to 2. So we are going to need this in the Nernst equation. And then for the Nernst equation, E is equal to standard cell voltage minus 0.0257 volts divided by N, and then Ln of. Okay, so what is Ln? So we are now going to include the concentration of the bromide ions raised to the power of 2, concentration of the hydrogen ions raised to the power of 2, divided by the pressure of the hydrogen gas. Okay, so sige pangita nato diri nga problem. We are looking for the concentration of the bromide ion. So nangita ta ani. So we can see that we are given the pressure of the hydrogen gas, so nata ani, and we are given the pH of 0, so we can solve for the hydrogen ion concentration. So pila may hydrogen ion concentration kung yung pH kay 0? pH equals 0. And also kaya ito siya, H plus is equal to 10 to the negative pH. And what is 10 to the power of 0? Pila mo na siya? That's just equal to 1, diba? So 1 molar di ay ang concentration. So we're going to substitute everything in the equation. So the given cell voltage is 1.71 volts. So we're going to use that. And then the standard cell voltage is 1.077 volts minus 0.0257 volts divided by N is 2. And then Ln of, we don't know the bromide ion concentration. And then for the hydrogen ion concentration, that's just 1 raised to the power of 2. And the pressure of the hydrogen gas is just 1 atmosphere. Alright? And then, atong ipuli, transpose, balin sa pikas. So this is 0.0257 over 2 ln of Br negative raised to the power of 2. So 1 raman ang uban. That's equal to 1.077 minus 1. So we're not going to include the unit anymore because we're going to cancel that already. Minus 1.710. And 1.077 minus 1.710, that's equal to negative 0.633. And then we're going to cross multiply. So Ln of Br negative raised to the power of 2 is equal to negative 0.633 times 2 divided by 0.0257. And that gives us an answer of -12660 over 257. And then what's next? We convert to exponential form. So BR negative raised to the power of 2 is equal to E raised to the power of negative 12660 over 257. And then we extract the square root to get the bromide ion concentration. So that's square root of E to the power of negative 12660 over 257, which gives us an answer of, that's 2.0099 times 10. So it's really small. It's really small. 2.0099 times 10 to the negative 11 molars. So this is the bromide ion concentration. It's really small.